Well, good afternoon, everyone, and welcome to our webinar. My name is Ren Shepis. I'll be one of the presenters today, and we're coming at you live from Deakin University, the Business School. And our topic for discussion today is on the screen there, which is data science in organizations, conceptualizing its breakthroughs and blind spots. Now, the webinar is jointly presented by myself and my co-presenter, Professor Jacob Cebulski, which I will introduce or ask him to introduce himself in a minute. In the background, we have our team from Deakin University to support your questions. And we'll go through how you could post questions, which we will take throughout the webinar through the chat forum that we will have. But let me first pass to Professor Cebulski to introduce himself.
Thank you, Rens. Well, I'm Jacob Cebulski. I'm associate professor in the Department of Information Systems and Business Analytics. I'm also a discipline leader for business analytics. My research includes business analytics, deep learning, and artificial intelligence with very strong business applications.
Thanks, Jacob.
Rens.
Thank you. So, so we welcome you, of course, in the middle of a very complex COVID pandemic. And I think many of you might be at the office, i.e. at home working. And so this is an opportune time to kind of just sit back a bit, just to revisit what the world of analytics can present. I also understand that many in the audience might be looking at if analytics might be a career for them. So a little bit later in the session, we'll talk a little bit about analytics education, and how we present that here at Deakin. So for now, what I'm going to do is we're going to start the topic, and I'm just going to go through how you might interact with us live. So you will find that on the bottom of your screen, there is a Q&A toolbar. And if you were to click on that, you could actually enter questions for the presenters, and they will come through our marketing team that's supporting us to me. So I might take questions, or Jacob, when he's doing his presentation, might take questions throughout. And that's how we can have let's call it a virtual discussion, which I think I would look forward to. So feel absolutely free to post questions. And we will either present, take your questions live, or we might get back to you with a written response, for example, if it pertains to things like information on courses or things like that. So without further ado, we might make a start. And I'm going to start by really thinking, or just giving a bit of an outline of what we'll be looking at. Now, the world of information systems, data science, analytics is a very complex world. So we're not going to go through the whole complexity of that, but we are looking at the uses of analytics and AI and predictive modeling, which we broadly group under the space of what we call data science. That's the topic for the day, but we are looking specifically at their application in the business context, right? Now we know that there's a lot of things you can do with AI, with analytics, etc. And we see lots of things in the popular media around the breakthroughs. But we're going to try and ask ourselves the following fundamental question: to what extent are those helpful, or to what extent do they enable business decision making? And are there limitations that we will be looking at? So we'll be focusing on limitations of data science in the business context. We're going to give you tools and a framework, which we will call the data science organizational framework. Quite often you can think of frameworks in the following way. So frameworks are, if you like, intellectual crutches. They help you think through complexity. In other words, when we look at complexity, for example, can data science be utilized for this particular business application? What are the benefits we might get from that? And are there any inherent limitations in the broad space as well? This is what the framework enables you to see through that complexity. It asks you, or it gives you vocabulary and principles that enable you to understand whether or not the application in that particular environment would work or not. So we'll be doing some examples of how this framework could be applied. And hopefully we'll be giving you some tools or an indication of the kinds of thinking that you could deploy as you might consider these kinds of problems in your own particular business context, whether you work in an organization or aspire to work for yourself as a consultant, etc. These are valuable tool frames or frameworks that could help you inform that decision. So the fundamental decision is the breakthroughs and the blind spots. How do we think of them together when we look at specific examples? So, so let's start with this particular discussion. So if we look at the world of data science, there are a lot of breakthroughs. There are things we can do today which we could not even dream of even a couple of years ago, right? So we are seeing advances in the area of what's called big data. You know, society is awash with data. There's data everywhere in organizations, in the broader social environment, your own information that you have in your house, your devices that involved in terms of capturing data, the Internet of Things. There's so much information around the world, and that becomes a resource for informed decision making. Also, the online world, social media, etc. We've seen breakthroughs, dramatic breakthroughs in AI, right? AI for many years was a bit of a sleeper area, and in recent years, significant advances have come to fruition. We can do things in AI not dreamt of before. I'll give examples. Self-driving cars, automated analysis of graphical images. In other words, if you look at an image, you can say, is this person happy, right? Is there a rose in this image, right? So automated analysis of very complex videos, etc. All of those are made possible. Here at Deakin, you know, we have something called the automated student support system. We call it Deakin Genie. It's an example of cognitive service automation. And just think of what that enables a student to do. So with a mobile phone as a platform, they could interact with Genie, which is of course our AI system, and obtain student support. For example, they could ask, you know, information about their content of their lectures. They could replay lectures using voice interaction with Genie as an AI platform. We couldn't have dreamt of these kinds of services, these kinds of intelligence services years ago. You know, look at the field of robotics, and you know the advances that we see in terms of manufacturing, robotic process automation. Quickly, we are saying that there is a dramatic sequence of breakthroughs in a variety of things that relate to this broader data science environment. And so when we look at these advances, you know, health AI, smart everything, smart products, you know, many of you might have smart home automation these days. We quickly jump to the conclusion that perhaps the sky is the limit. You know, this is just a fantastic era that we're living in. Or is it? Or is it? So that's where the focus of this presentation sits today. We are looking at the business context. Now, I don't need to give you a breakthrough on how things work in business, but we do know that the business context, in contrast with the broader scientific environment in which a lot of these innovations are being positioned, is slightly different. The data in business is different. They tend to be social scientific data, not scientific data. And so there are peculiar things about the data science application in the business context that we need to unpack and understand if these are things that limit our aspirations in terms of where data science application can be. And Professor Cebulski that I work with always tells me, and you have to say at this point in time, because we do not know what the future looks like, right? So when everyone tries to predict the future, they're usually wrong because there's a new innovation in the future. So we will contextualize everything we say here by saying at this point in time, given the current state of technology in this area. So, so let's look at the potential blind spots, right? So we've looked at the breakthroughs, you know, you can look at the popular media for those, etc. But less is known about its blind spots. And so the question that we are looking at here is there are some particular applications of data science to the business environment where it seems to be really well suited, and we'll look at those, right? But there are also some problems that don't exhibit these characteristics, and therefore, for those types of problems, there might be certain blind spots when you look at the broad data science suite of offerings. And so already what we're saying here is the first argument, it kind of depends on the application that you're looking at. Now, it sounds obvious and intuitive, but we need more vocabulary. So we're going to unpack what that means. We're also going to give you some ideas of how you could think of it, again, using well-trusted theoretical concepts as lenses to understand the situation a lot better. So let's see how we might do that. So Professor Cebulski and I have been working on a piece of research, and that piece of research is about to, if all goes well, get published in the near future. We will know very soon in the next few weeks. But we are highlighting that many data-intensive business problems are situated in really complex socio-political and behavioral contexts. And because of the socio-behavioral context behind these environments, they elude the scientific methods and applications in which data science is rooted. Okay, now that's a bit of a mouthful, right? But let's try and unpack that a bit more. So we're saying that if you think about the limitations or the blind spots in data science, it relates to the application, but it also relates to the specific components of how you might deploy that data science solution. It relates to data. It relates to the methods, and there are also limitations in methods. It relates to the interface that you might have in terms of decision making and how you might interact with the data science application. And it also relates to the fundamental cognitive limitations that we as human beings have, right? So we're going to unpack those for you in the next couple of slides. So let's take data itself, right? Now, yes, the world is awash with data, as I said at the onset. But if we look at the business data space, right, we find a number of problems, a number of limitations, right? First of all, some data is just not available, right? Some of the data we use in decision making is biased. What do I mean by biased? In other words, if you walk around and ask for an opinion on something, people will give you a particular view as they see it, and that might include bias, right? It might also be a view that they say, but they actually believe something fundamentally different, right? So in other words, we see this, especially when you try and go back through some of the predictions that we find using data science methods to predict, for example, things like election outcomes, right? The predictions are wrong purely because the data itself has limitations in it because it exhibits bias. And even though you have data and you can analyze that, and we have lovely ways to analyze data today, the underlying assumption in the data is incorrect. And therefore, surprise, surprise, you make an incorrect prediction. Those of you that work in business knows about silos, data that lives in silos. Yes, we have lots and lots of data, but it's fragmented. It's in different systems. It's very hard to bring them together, to integrate them. And even if you could do that, quite often you lose some of the richness of the scope that is implied, right? So if you look at process information, it is extremely hard often to have an end-to-end perspective. So we say our data is fragmented. Importantly, and this is an insight that Professor Cebulski came to realize, he came to me one day and he said to me, Renz, the problem with data in the business context, it's not smooth. And I said to him, Jacob, what is smooth data? And he said to me, smooth data is scientific data. So those of you that have an understanding of the field of calculus would know that if you've got a smooth, continuous curve, you can fit tangent models there. And calculus is at the heart of many data science methods, right? But what happens if your data is not smooth? Well, then you can't make those assumptions. You can't utilize those data science methods because your business data is fragmented or it's not smooth. So if we were to look at the second limitation, and we're talking about the world of methods. Now, people say that a lot of the data science breakthroughs that we've seen was really attributed to more data, big data. We talk about these things, but realistically, that went in tandem with an explosion, an absolute explosion in the range of methods that have become available. So the mathematics that drives data science in recent years. So if you know the technology field, you know that there are a variety of platforms out there where there's an incredible amount of innovation that's happening around different ways to analyze data, things that are becoming possible that we couldn't dream of because the mathematics of analysis have advanced. For example, convolutional neural networks, deep learning, all of these incredible breakthroughs that we are seeing arises out of methods, new ways of thinking, and much of that's done in collaboration around the globe, and much of that's available to us free today through a number of platforms. You know, you can download the most amazing sophisticated functionality for your data science application today. But we should also realize that even those methods, or some of them, are limited. They're limited in a number of ways. I'll just give you a classical example. Those of you that work in production control environments would know that, you know, to try and optimize something as simple as a production schedule is not always computationally possible, right? It'll take you something like 10 to the power 20 years to compute all the possible scenarios. And therefore, you're back to making heuristic or suboptimal decision making, because even though we have fast computers that can do amazing things, the nature of the computational task still says it is not possible, right? That's a limitation in method, right? Moreover, we have limitations in terms of our interfaces, right? So if you think about the complexity of interpreting data, and in the laboratory that Professor Cebulski managed, we have a lot of research being done on visualization, and in particular how business decision makers react to and correspond to complex data visualization. So for example, if I'm presenting a simple 2 or 3 dimensional set of data to someone, they can understand it. You know, we're trained with, you know, trend lines and charts and so on. But what happens if that data is 10 or 15 or 20 dimensions, right? Becomes very hard to understand what that looks like. So some of the research we're doing is on the topic of what metaphors enable business decision makers to effectively interact with complex, you know, visualization, and to come to an understanding of what the actual data science is telling them, right? It's not easy. It's not easy. So again, there are limitations in terms of the human tool interface. And the last one that we focus on here is really just an aspect of human behavior, right? Complex phenomenon are complex things, you know. Would we love to be able to cure cancer? Of course we would, right? We just don't understand the phenomenon, right? Have we had breakthroughs in a variety of different types of cancers over the years? Absolutely we have. Are we learning more about this? Absolutely we are, right? But fundamentally, some of the complexity of phenomena that's being dealt with, and importantly, in the business context, and we're going to give you some examples of those, are just, you know, we just don't know. We literally do not know. And therefore, predictions and even telling our data science tools, you know, what kind of attributes to include in our predictive modeling, which ones to exclude, is confounded by the fact that we as human beings don't fully grasp these phenomena. They are so complex, right? They are so complex. If you understand also human behavior, we have this aspect of bounded rationality. So what is bounded rationality? Bounded rationality says, well, decision makers sometimes use the science, but sometimes they don't, right? In other words, they are bounded in terms of to what extent they are open to scientific explanations versus, if you like, seat of the pants decision making, right? And so this bounded rationality quite often interferes with the kinds of understanding, the kinds of ways we look at complex business problems. So what I'm going to do now is I'm going to pass to Professor Cebulski, because we've done some background work on these 4, what we will call domains, right? 4 domains of data science. This is the vocabulary that we use to look at its limitations and its breakthroughs. And we're going to tell you how we arrived at these 4 things. You know, whenever you draw a list of 4 things, everyone, at least in the research community, will say to you, how did you get to this? Prove to us that these are sensible ones. And the answer sits right there. So Jacob, over to you.
Thank you, Rens. Just a reminder, the aim of this research was to identify advances and limitations of data science in relation to human problem solving and human decision making in business context. So keep it in mind that we are trying to assist people in their decision making in this complex business world. So how do we start such investigation? And of course, there's a lot of people before us who wrote scientific papers in this area. They showed how to apply data science techniques, methods, technologies to solve business problems. And so this is how we started. We started looking at collecting sources of information previously published and vetted for their quality in a variety of scientific journals. And so we collected, selected, and we classified numerous articles from journals such as the basket of 8 top information systems journals. And we looked at journals which are interested specifically in organizational decision making. And we also, through the database systems, literature database systems such as available in Deakin Library, we use keywords and searches to identify many other journals. Often those databases give you recommendations. So once you find one article, the database system says, however, there is also several other articles which match what you're currently looking at. So in total, we identified 424 papers, which we collected, downloaded, and looked at the titles and abstracts. And from this preliminary investigation, we found that 294 papers are right on top of the topics that we're interested in. And so in this initial investigation, we also tried to classify those papers by hand into those 4 domains, whether the paper supports some argument in relation to data or methods, interfaces, or human cognition decision-making. And we also looked at the abstract themselves. So we have downloaded those abstracts and we used a tool called KHcoder, which allows us to do some text analytics on those abstracts. So what text analytics is actually, it's a method, it's a data science method which splits the text into words, identifies performs lexical analysis of those words, identifies whether the word is noun, it's still previous one, thank you. Identifies whether the nouns, the words are nouns or verbs, and it identifies relationships between those terms. So what we're looking at here is one of the explorations of those papers, which have been split into numerous terms, and those terms are interrelated across those 4 domains. Now, what we worried about at this stage is that the classification which we performed was our own classification. We used our own judgment, and our judgment is obviously biased, especially at the very beginning of this research. So we looked at the second stage of this analysis, where we abandoned our own classification and our own understanding of the field, and we tried to rely on the data itself. What the data tells us about the nature of those 4 domains, whether those 4 domains could emerge from data in its own right. Next slide, friends. So what we're looking at here is our second stage of analysis. The first stage was what we call supervised. That means we actually guided the process of classifying those texts, the abstracts of those almost 300 documents. In a second stage, we decided to rely on the tool to identify the relationships between the words in the documents and between documents to documents. And we used a technique called co-occurrence analysis, which looked at how the words occur together nearby within a sentence or paragraph or the abstract itself, and try to look at how the words themselves appear across many documents. Now, what you see here is the result of this analysis in which the tool on its own, in an unsupervised way, identified groups of the terms. It colored those groups because they are so tightly interrelated to form groups which we call communities. Those communities become the seeds of our understanding of what the texts are actually talking about. Now, what you see here is a very large structure, but didn't come like this to start with. We used KH code and co-occurrence analysis when we started looking at initially only 40 terms or 50 words extracted from this massive number of documents, then 50, 100, 150. And you can see here we have a list of our experiments, how many links between the words we investigated. And so they started forming more and complex picture and more complete picture of the domain of data science in business in respect to those 4 domains. And those domains were identified. You can see them here. They're quite obscured by the richness of interrelationship between pictures. And we try to abstract away from the words themselves. And we identify the domains as consisting of those communities of interrelated concepts. So what fascinated us is that this pretty much matched our preliminary idea about what data science is all about and how it is interrelated, but it emerged purely from data. So we simply labeled those domains, we labeled those communities. So this is the extent of our manual labor put into it. Everything else came from data science, text analytics. So we moved to the 3rd stage of this analysis. And the 3rd stage was much more complex. Next slide, right. Since this is, we worked on a scientific paper which we hope to publish in very eminent information systems journal. That analysis had to be grounded in the theory. And we're looking for suitable theory to capture this understanding that emerged from data in this research process. We were looking at applying principles, the fundamental principles describing interactions of socio-technical systems. And one of the theoretical approaches is cybernetics. So we looked at cybernetics principles to understand the opportunities afforded to organizations by data science while solving some socio-technical problems. And what's cybernetics? Cybernetics, actually, the whole idea of cybernetics goes back to 19th century, where people try to understand how biological systems work and how engineering systems work. And one of the founders of the cybernetic area is Norbert Wiener, American mathematician and philosopher, who defined it in 1948 as the study of control and communication in animal and the machine. So that's how it started. There was also formulated some first order and second order cybernetics. The first order looked at the theory of very simplistic systems, such as thermostats, which could could measure the room temperature and adjust some air conditioning or fan system to reduce or increase the temperature. But the second order cybernetics was much more complex. It looked at self-organizing or self-learning systems such as human or society, which the system could interact in a very complex way with the environment and adjust itself. In fact, it could transcend its own capability by learning new ways of changing the environment. So in a sense, the first order cybernetics is about observed systems. The second order cybernetics is about the observing systems. And the system is humans. The systems is group of people, the society, the organization. And one of the people who had a tremendous impact on the area is Ross Ashby. psychologist and system theorist who refer to cybernetics as it's about things, not things, but about ways of behaving. So we're not interested in the artifacts, the objects, people. We're interested how they interact with each other, how they behave. So the cybernetics asks the question, what is not what is this thing, but what does it do? He formulated a very profound law of requisite variety. And this law tries to explain exactly how systems work. So the law states that the variety of the regulator needs to exceed the variety of the phenomenon to be controlled in order to achieve homeostasis or equilibrium. So what is variety? Variety is a measure of complexity. And basically it's given in terms of how many different states some system could take. And the idea is that if you want to control some phenomenon, let's say a car on the road, your variety must be greater than the variety of the car. So you're the regulator, you are controlling, and if your variety goes below the variety of the environment, of the car on the road, you're likely to crash. And how this variety of the car could change, either by increasing the speed of driving, by bad weather conditions, by other cars on the road. So there must be some way of assessing and determining variety of systems. And that variety needs to be built into the system so the system could suitably respond to the environment. This is the idea we try to apply to our thinking and the data which emerged from those articles. By the way, there is also another famous researcher in this area, Stafford Beer, who actually looked at applying cybernetics and in particular the law of requisite variety to business. And he coined an interesting phrase saying that only variety can absorb variety. Okay, so you need to be able to deal with complexity by increasing the complexity of the regulator. Now, the result of this thinking of how to apply the lens of the Ashby's law of requisite variety to our data, we came up with the model which captures all the elements which emerge from our investigation thus far. So we looked at data, methods, interface, and cognition, and we tried to judge what should be the variety of those components and how they should interact so that the organization that is using data science to solve their own problems could first identify the weaknesses they may have and identify the strengths which could overcome the weaknesses. And from the previous slide, you will see that what you see below here in the blue area, this is the things which came as the strengths of those 4 domains of data science, such as existence of data, vast repositories of data, real-time data available to business. This is the strength of business. Of course, when the volumes of data are available, that causes problems for business because it must have appropriate methods of dealing with that volume. The data is voluminous and fast changing, very quickly getting outdated, which means that you need to have hardware and software and mathematical solutions of dealing with that volume of data. So we have those methods which are specifically dealing with data. Now that data and methods need to create decisions and problem solutions which must support humans. And the humans are supported by interfaces. And of course, our interfaces emerged as very complex and new, which need to deal with ways of collapsing and aggregating the data and presenting the data in very specific ways that humans could actually understand and make decisions. And so we have visualization tools. We have also vocalization tools. We have devices sitting at home, listening to what we say and adjusting lights and switching channels on TV. And there's a variety of interactivity with methods and data which are available. And the world is moving very fast. The companies are creating new devices which help us to deal with that. And of course, Rance mentioned we have limitations, cognitions. Now, all of those are our advances, but we have many, many limitations in each of those domains. Data is still poor quality. We have huge volume, but it may not be accessible. High velocity, rapid methods are computationally challenging. They're usually developed in specific, very narrow domain solutions. And we have human factors which affect effectiveness of those methods. Interfaces are abstract, unstructured. We have a lot of user interfaces which cannot be comprehended by people, cannot be shared by groups of people. So we have technical and social problems of using the data and methods. And of course, cognition, phenomenal complexity, and our cognitive limitations are putting stops to that. The idea is that if we have a limitation in one area, we could work on better methods or better interfaces to support people. And so if we have more data, we need to have more methods. Those methods and data could provide decision support, which will reduce our cognitive workload. And so we could actually start looking at solving new problems in the world, which will create new data, which will need new methods. So it's a complex interaction between those four domains. Now, Rance is going to give you some examples of how this model could be used to support business. Thank you, Rance.
Thanks, Jacob. So let me just try and you know, I know this is a mouthful, but let me try and put it to you this way. What you're looking at on the screen is a model. That is a model for how organizations could decide whether a particular phenomenon, a particular challenge that they might want to take on through data science can be done by them as regulator or the organization, considering limitations and opportunities in both method, data, and cognition, etc. And what we know is that some of these limitations that might exist in one area could be overcome in part by developments in another area. So for example, we might not know how a particular virus progress works, but if we have data that informs us of that pattern, we gain understanding. So there's interactions between these domains. And the reason why we presented this one is because it is actually exemplified in, you know, the actual theory and literature. And that's why you would expect in a paper and a piece of research on data science, we would actually use data science, in this case, unsupervised text analytics, to inform the model, right? So let me now say how this model could be used in your context. Now, we've had some great questions throughout. And so maybe if we look at some examples where we apply this model, we could give you a sense of how this insight could be very helpful in your own context. So let's look at some examples there. So I'm just going to go through them fairly briefly because many of them you will well understand. So in a particular pizza chain here in Australia and globally, they're actually using data science in the form of cameras that look at pizza quality, visual images, and then they're given a rating on the pizza. Right now, you might think, how can a machine do that? How can data science in this business give a rating? And of course, if it's not good enough in terms of appearance, composition, etc., the machine might say probably redo that pizza, right? Let's look at it from the perspective of this framework. So first of all, we've got data. We've got lots of unstructured and structured data about what well-cooked pizzas might look like. We've got the method. We've got image analysis through deep learning. You train a machine on recognizing images, right? We've got a very simple interface. It gives a rating on a pizza that business decision makers can easily understand. Let's say out of 10, 1 out of 10, or whatever the case might be, or 10 out of 10. And it's essentially a replacement of the intuition where people are very busy, etc. You bring the machine in that gives you a much more clear analysis, and therefore we say for that class of problem, this can be solved by data science. All of your 4 domains have opportunities, have got breakthroughs in them that enable that to solve the problem, and there are no significant limitations in there. So all of the text in blue are the good things if I go back to the model that we presented earlier on. Red things are limitations. So if I look at things like traffic congestion, right? Traffic congestion, yes, we've got lots of data. We've got cameras on the streets. We've got aerial photography. We've got real-time data available through sensor networks embedded in roads, etc. The problem that we have with method, it's computationally challenging to take all of that into account in real time, right? And therefore things are short-term predictable, but we still don't have absolute assurance. And of course, accidents can happen at any point in time, right? So you have at least some short-term predictable. If there's an accident here, it's going to clog up, etc. So again, there is some significant improvement that we can make to that business decision making. So for example, if you're a city government or a roads authority, it's made significant advances to the situation because across all of those 4 domains, there's been dramatic improvement in recent years. Those of you that work in areas such as retail, etc., where you're dealing with customers, you know about the concept of customer churn, right? These are customers that leave you, they go to the opposition, etc. You want to try and predict churn, right? You want to try and predict the ones that are likely to leave you. And how can we do that? Well, we've got fantastic data. We've got historical trends. You might keep that on your own records. There was a question earlier around small organizations. Yes, absolutely. They've got good customer records. And you want to know, what is the probabilistic modeling, the chances that a particular customer might churn when we look at past behavior of those that have churned. And you can train predictive models to give you a very good probabilistic churn modeling prediction. And of course, we can go through that in great detail, but the problem that you have is that we still do not know the reasons for churn because it's a very biased emotional reason that sometimes happens. You're upset with a particular product or a particular service experience and you churn, which is not predictable by the data, right? So while churn can be significantly improved, there is a big problem that you still deal with this social behavioral context that intrudes on that particular prediction. When we look at much more complex things like stock market predictions, there's a sea of red there, a sea of red. And the reason being is that much of the data is not reflective of the actual emotional behavior that sits in those markets. People react emotionally and their behavior around trends, etc., is just not there, right? We have very large patterns of abstract, complex, and irrational decision making that limits the ability for predictions. And that's why we know that for stock market predictions, data analysis, of course, informs and helps, but is often wrong. The last one that I mentioned there is the cyber attacks. And the problem that you have there is, again, it's both a data problem, it's a methods problem, difficult to visualize, etc. And fundamentally, what is the problem here is that once you try and predict a particular cyber attack, of course, the bad cyber attack criminals devise new methods. So when you learn a pattern and behavior in one area, they invent a new, more insidious mode of attack, right? So this is almost like an ongoing arms race, and you're forever more one step behind. Once you've trained your machines on the current patterns, then they devise new forms of attack. I think you can understand the logic. So the point that we're making is these models help us think. And if I were to summarize what this means for your business, right, and I'm going to conclude with this, is our central argument is that the advances in data science that we see around us in aggregate across those 4 domains of data, method, interface, and cognition have enabled a lot of organizational solutions to particular classes of problems. For some of those problems, there's just an insufficient level of variety. This is the cybernetic variety that Jacob spoke about in one of those domains or one or more of those domains. And it could be just limitations in data science today. So when you have a limitation in one of these domains, in other words, one of those things are red, right? Then you have to say, look, is there the opportunity for cross-domain variety? In other words, does it efficiency in data, could that be compensated for by a new smart method, right? Or a better interface? Or conversely, could a deficiency in our understanding, the cognitive understanding of a problem, be compensated by more data, more insight about what the problem looks like? If so, then you can make these advances. Then you can make some inroads. You're not going to solve the problem, but you're going to make significant strides ahead. But if those problems are so insurmountable, those limitations in one of those 4 domains are so insurmountable, then you're sitting in the space of your last, where there's just a sea of red. You've got very limited application of data science for those kinds of problems in the business context. So I might conclude at that, which is our broad argument. And I'm just going to respond briefly to some of our questions in there now. Many of you are posting questions through the chat, and that is fantastic. And I see a lot of us are responding to those questions. So please keep doing that. I'm going to briefly turn now, because I'm mindful of the time, just to some of the broad, if you're interested in these topics, and I'm very encouraged to see so many questions coming through there about how you might use data science in your organization. Perhaps you're thinking about a career in data science, and perhaps you're thinking about, if you're an existing career and this is interesting and you can actually see that this might be something you want to get involved in, where could you start? So let's have a look and see what's available here at Deakin. So we have a variety of academic programs that you might turn to. We have a Master in Business Analytics. In fact, ours was the first Master of Business Analytics in Australia, right? Others have copied us since, of course, but you can have a look at our Master of Business Analytics program. We have a Master of Information Systems. I'm going to briefly give you a sense of what these programs look like. We've also got, if you don't want to make a long master's commitment, we've got shorter courses. We've got a graduate certificate, much shorter program in information systems. We've got one in artificial intelligence, and they are geared for the business user, right? So one of the questions that came up early on, do we need programming? The answer is no. Okay, business users typically do not develop algorithms and programs, they use them, right? It's a bit of the analogy of driving a car. You don't need to understand how the engine works, as long as you understand the fundamentals, that you can actually make sure you service it and, you know, control it, etc. The application is what we're focusing on. So for us, it's about developing scripting, modeling. Of course, we're going to expose you to the tools of the trade, all the industry tools. We had some questions around SQL, R, Python, etc. I'm going to look at some of the tools that you will encounter in our program. We select partnerships based on industries and industry tools that are used in business today. We want you to be familiar with these tool suites, because that makes you familiar with the products. Can you apply them? Can you use them? And can you put them in place in business? So if I look at our two master's programs, these are some of the topics that you will find in those programs. The big distinction between the business analytics one and the Master of Information Systems. Information Systems says a bit of analytics, a bit of data science, but more focused on project management, your typical business skills, in other words, you know, resource business requirements analysis, those kinds of things that are sort of more business systems and a bit of analytics, right? Whereas the Master of Business Analytics program says it's full on analytics, data science, analytics, applications, etc. And in all of these programs, you will work on live, real world problems, and will give you all the foundational skills. And you can see some of those topics in there that it will equip you to be able to become fully active in your career and develop a new skill and perhaps a new career altogether. Of course, if you have industry experience, we do recognize prior learning, and there are a variety of recognition for that. That will mean your program will be much shorter, because we will recognize your prior experience. I am mindful that many of the people in our audience that are actually working and have significant working experience. So the university will credit your experience and develop in the areas where you then need new skills. There's a variety of pathway entry requirements. So for example, you might say, look, what do I need to get in? Well, you know, there's a variety of suites. I've given you a bit of an overview there, depending on whether you have a graduate certificate, a previous bachelor's degree, how much work experience you have. That'll give you an indication of the credit points that you could aggregate and where you would then steer in terms of your entry into the programs, right? So these are the kinds of things. And by the way, the session is recorded. So if I do cover some of this material and you want to return to that, a recording will be made available for you, and you can go and look exactly at that. And we'll give you lots of links and references that you can interact with us afterwards if you're interested to pursue any of these pathways. So here's our graduate certificate programs. These are shorter programs, you know, half years full-time or 1 year part-time. Many of us, our students are part-time working students. You're looking at someone who's been a working student all his life, right? So in other words, very familiar with the idea of working and studying part-time. We are now entering in an opportunity where digitalization is everywhere. AI is everywhere in business. Society is looking towards AI, the transformation, digital transformation in supply chains, in accounting, so many business disciplines, human resources, right? So in other words, these skills will stand or hold you in very good stead for the next couple of years moving forward. And certainly in my view, if we look at the employability of our graduates, these are very good skills for you to move forward in terms of career development or career changes. So why might you choose Deakin? So, well, first of all, we have an extremely well developed online flexible learning suite of offerings. You could be working at your office and studying with us, right? There's a whole suite of support and digital support because we were the pioneers in digital learning in Australia. And this goes back, would you believe, to the 1970s. This extends well beyond, a Zoom chat, right? This is much more around the way that we interact with our virtual laboratories, the way that you would interact in terms of student support, the way you would work together. For example, we have students, breakout rooms, etc., and they're all done virtually. And more importantly is we are utilizing all the industry tools that are commonly used today. So I've given you a list of some of them there. We've had questions in the chat around R and Python. Yes, we are using those, but we don't want to turn you into a programmer, right? That is not the intent here. We want you to be familiar with these tools and modeling approaches where you could utilize and deploy them in business. Fundamentally, we are training for you for a career in business decision-making, business analysis, right? So these are some of the partnerships we have with IBM, RapidMiner, SAS, etc., Tableau, and so on. We have a whole suite of products. Why those products? Because they're used by industry today. More importantly, is we also have our programs accredited by the Australian Computer Society. We do that for a very specific reason, and that reason being that it gives you professional standing in the discipline. And also, we believe in the world of analytics and data science, it also gives you the code of conduct around what is considered professional practice versus not. As you might know, technology enables you to do a variety of things that's not necessarily good for society. And so the ACS has a code of conduct that says a professional, person working with business analytics, these are the code of conduct that we would want as a society to ascribe to that individual. So I'm going to pause there. I'm going to go through the chat and I'm going to just take some responses to particular questions that came through there. And I'm going to turn to my academic team, sort of my Deakin team. If there's anything that I've missed and that is a question there, I'm happy to work through those.
There's a question from Ranga.
Yes, please.
About,
go ahead, Jacob.
This content, whether this is published, has it been published, and can it be cited? So this presentation is actually the subject of our paper that we're writing, and the paper has been in the review for the last 2 years. So you have to understand that to get into one of the top journals, it takes a long time. However, if you put your name and once it's published, we can get back to you and send you a proper copy of the paper. And in the meantime, you could cite this presentation, which is available as a video.
Yes, correct. So of course it's research that's attributed to myself and to Jacob. So and it's currently under review. We expect this would be published in the near future. And when I say near future, we're talking weeks from now. So we're at the last stages and have been working with the review team for quite some months. And so this is quite important work, we believe, for the field. And more importantly, it gives a tool. It gives a tool to business decision makers. It's a bit like these pair of glasses I'm wearing. If I put them on, I can see through complexity. I can see through the decision making that I need to consider whether a particular problem that occurs in my business would be addressable through data science, and also then to say, look, where are the limitations? Where are the issues that might impact that decision making?
You also add that the model we've just presented, we use that model for our other projects. And so we have a suite of publications coming in that area. So once you become students, you'll be exposed to more of our research ideas, and we have teams of researchers who would be more than willing to take you on the projects, and you could participate in research of that kind and do some real life analytics on organizational data that we have a lot of partners that we work with on their projects and their problems.
So just to dovetail with what Professor Zabulski said, there is what is important in the world that we're working in is that you dovetail the research space that you're working in. So in other words, the people that educate you do research in that particular area. They're not just grabbing a textbook that someone else wrote and says, here is the material, right? They actually work and do research and create the knowledge for the area, as we are doing here. We're creating this knowledge. And of course, in our greatest scholarly journals, this is where we are, right? They're happy with this kind of thinking that's been done here at Deakin. And they say that is good for the global disciplines understanding of where the limitations and blind spots of data science is, right? So it's important to have that understanding. The academics that you'll encounter work and research in the areas that they teach, right? So just before I stand back, the programs at Deakin has a distinctive focus, and I'm going to give you that distinctive focus as well. So these are all our programs, the masters, the graduate certificates, etc. The focus is very important from a employability perspective. When we talk to prospective employers, right, and the way that you think about people that might be considering changing career, they tell us a number of things. When we ask them, what do we educate our student community in? It's very clear to us there are three broad pieces that they want us to take on. The first thing, of course, and the topic of our discussion today is the skills and the methods around analytics, information systems, and so on. So they say, teach them the domain, industry use, practices, tools, methods, etc. Right? And of course, that's what you will encounter in the program. More importantly, or sorry, I should say, as important as that, they also say to us, this is a business school, right? We want your students to work in the area of business. So without the business context, in other words, the business problems, you're teaching them solutions without an understanding of the problem. Teach them, in addition, the business logic, competitive advantage, operational efficiency, trade-off analysis, the kinds of things that business decision makers and the kind of decisions that business has to make to compete, right? So competitive strategy you will encounter. The value of information from a business decision-making perspective you will encounter. Complex business decision-making where the tools, etc., and the solution might be only partial because that's what an organization can afford. They can't afford the full solution, and therefore, where's the middle ground? Those kinds of trade-offs requires an understanding of the broader business context, right? And especially those of you with a technical background, we will backfill that because we are a business school. The last component that they are quite fundamental that we also teach is professionalism. Now, professionalism, we all want to be professional, but there's a whole suite of skills that we can add to your content of your education that enables professionalism to rise, such as, right, we can teach you how to develop professional business cases for investments in information systems and analytics, right? What does that look like? How would you present that? How would you present that to a board? And more importantly, let's give you the experience of presenting your proposal to senior decision makers, right? That's what you'll encounter. So for example, in our capstone units, in all our programs, we have capstone units. We bring a real life client into the classroom. You work as student on that particular client's data, their problems, their business context. You immerse yourself in their context. And at the end, you present to the management of that organization's your solution, right? They give you feedback. They tell you this is good, or have you thought about this, or fantastic. And I should say that many of our student projects, when they were presenting it to the business would come back to us afterwards and say, that is fantastic. That is what we actually learned something from your students, right? And the ultimate test for us is if our students are able to advise a business on things that matter for their competitiveness, for their advantage, which the business didn't know and which our students could derive from their skills, from analytics, and from the kinds of experience we give them in training. So that's our focus at Deakin, those three domains, the professional side, the skills development side, and the business context side. They work together to give you the very best opportunity of progressing in your career or finding that beautiful new job. So I might leave it at that. I'm mindful of the time. We've just run out of time. And so I'm looking at my Deakin support panel, and they will probably conclude the session. Again, Just to remind you, things will be recorded. The variety of links here, sorry, I should put those on there. There's a variety of information links there, follow-up ways to get in touch with us. And please, I would encourage you, if you're interested in these areas on either the topic of research or the education programs that we interact with through our Deacon, please follow up with the team. We'll be in touch. And as I mentioned, all of this will be available for you as a recording afterwards. So I might conclude with that and pass to Jacob for a final thank you.
Well, thank you, Rens, and thank you for all the participants in this seminar and the audience, of course. There were some questions about what's next after our degree. Of course, this is only the beginning. There is a lot of opportunities to get into industry, keep in touch with various associations and groups of people, and always learn more and more. So we are going to teach you not only the contents, but also how to learn more in the future. So thank you so much, and thank you for listening to this presentation.
All the best. Thank you.